So at this point I'm ready to go ahead and start my program. So everything that we write in this next part is going to be located under the task main. You have to have a task main because that's what the ROBOTC compiler is actually going to read whenever you run your program. So it avoids all these comments and then it reads the task main. So everything that we need to create for our program actually has to go between these braces here. So what we want to do is we want to start with our first command, and the better that we write our pseudocode, the easier it makes this programming part. So the first thing that I'm going to write is to start my write motor. So before we actually start working on the program, I want to make sure that I've set up my motors and sensors. So I can do that one of two ways. I can go to Robot and I can go to Motors and Sensor Setup, or I can click this button right here. It does the same thing. So what I have here are all my motors, and so for our test bed we're going to use two motors, and we have analog sensors and digital sensors. So the motors that we want to use are going to be located in port 2 through port 9. If you look on your Cortex, you'll actually see that port 1 and port 10 only have 2 prongs. And since we want to use a motor controller, which is 3 prongs, that's in ports 2 through 9. So I'm just going to use port 2 because that's what I have it set up as. And I'm going to call or create a name for my write motor. And you can make it as simple or complicated as possible, but I'm going to go with RM. Nice and simple, easy. And then I'm going to click OK here, or it may make you click Apply and then click OK. So now whenever I do that, it's going to make a little configuration note here on the first line of your code. So when your compiler goes through and reads your program, the first thing it reads is a configuration for your motor in port 2 that's going to be referred to as RM. So anytime the program sees RM, it's going to know that it's referring to a motor plugged into port 2. So that's going to come in play in just a second here. So when I create my first line of code, I actually want to take and tell the Cortex to start my write motor at full speed. So in order to do that, you can go into your natural language here, which has all your commands, and I want to actually start the motor. And you'll notice that a bunch of information pops up when I roll my mouse over it, and it also gives you kind of a template for this text function. So I can come and I can drag it here, and then I can change it to whatever I called the motor, which is RM, and then I can adjust the speed. So you want to make sure that the speed is anywhere from -127 to 127. So you want it at full speed, so I'm going to put in 127 there. So there I have my first line of code. You notice that whenever I have the start motor command, there's a capital M here, and it also turns like a dark blue. So ROBOTC is really good at using colors to help you understand and make sure that your program is working properly before you compile. I also have a semicolon here, and you're going to use these at the end of each line of code, or at the end of most lines of code. So after I have turned the write motor on at full speed, I want to wait 3 seconds. And so there's actually a command for wait, and it's under wait, and I'm going to just do the wait time here because that's in seconds. I could do the milliseconds and be really specific and write in 1,000 milliseconds, which is just 1 second, but for this case I'm just going to do wait. And you'll notice if I'm actually typing the code, I have this little pop-up here that pops up some suggestions for the code. And once that comes up, you can actually select any of these and double click on it and just continue typing. So I want to wait for 3 seconds, and I just have to type in 3 inside of this bracket and then another semicolon to end the line of code. And press the enter, and then we're just going to keep writing this and keep writing our code. So then we're going to stop, and then capital M motor, and so that pops up here. If you notice that yours is not popping up, you can go to view and make sure that the code completion is selected, and that will help you to write your code. So I want to stop the motor RM, because that's the one that we started 3 lines ago, and then make sure to put in my semicolon. So I'm going to fill this out at my own pace from here on out, and so you can pause the video and go at your own speed, and do it to at your own speed. Make sure you're following your pseudocode. seconds. Stop. So there you have it. Once we have finished our code here, then we can actually start thinking about going in and compiling our program. So when I compile my program, what that's doing is it's actually going through and just checking my program to make sure that it works before I actually load it onto my Cortex. So it's just a way of checking your program. So what we're going to do is we're going to compile it. I'm going to click the compile button. It'll tell me down here that it compiled successfully. And it tells me when I did that in the file that it compiled. So let's say that I had an error. So the compiler is going to help us fix errors. So let's say that I forgot to put a semicolon here on line 34. It's going to give me a little yellow X, and yellow X's are just warnings, and it's going to tell you the line where the warning is, and it's going to say that it's missing the semicolon. And whenever the compiler looks over this, or sees this error, because it generally knows what you meant in this program, it's going to kind of overlook these warnings and still run the program. So if you have a yellow X here, it'll still run the program. It just means that it's not 100% like ROBOTC wants. So if we actually made a more significant error, like we called this write motor, and we forgot that it was supposed to be called RM, and we try to compile it, then it's going to give me an error message and says that it couldn't complete the compiling of the program, and it gives me a red X on line 34, and it says that there's an undefined variable, the write motor. It doesn't know what write motor means. There's no configuration set up for something called write motor. So in that case, I would go back in here, and I know that I need to fix this particular line of code and call it RM, and then it will successfully compile. So now what we can do is actually load it to the robot and see if it works. So let's try that. So what you can do is plug in your USB and make sure so once I have plugged in the USB, then I can click download to the robot. Now if you get an error, like an error that says that the main battery is not powered on like this, then that means you need to turn the robot on, or you may get an error saying that it's not working. If you get an error and it is turned on, you can try cycling the Cortex, and that means turning it off, unplugging it from the USB, and then plugging it back in and turning it back on. That's called cycling. So I'm going to make sure now that it's turned on. So now it's turned on, and then I am going to try and download it again to the robot, and it should work successfully. And then we're in a mode that's called debugging. So what this is going to allow us to do is, while the robot is still connected, I can actually run the program and see how it works. So let's do that. If I click start, it's going to run, and it's going to start my program. So it goes ahead and it turns on the motor. We see that it waits 10 seconds before it starts the write motor again at half speed, and you can be verifying this on your test bed that it's working right. So it runs the write motor at half speed for 3 seconds, waits 2, and then runs in the reverse direction at half speed, and then stops the motor. And now that there's no more green highlighted, that means our program's finished. It's done. So that means it's going to work properly. So now what I can do is now that it's loaded onto the robot, I can close the debugging window, and I can actually unplug it from my USB and turn it off. And so now every time I turn the Cortex on, it's going to automatically run this program and start the program. So there you go, the ins and outs of starting your first program in